Hello, everybody. This is a review of lab number 4, paired t-test. And just like the previous one, I'll just review the answers. And so the first question is always going to be outline the steps in SPSS to do the thing. The thing in this case is the paired t-test. Let me close this output. So just do bullet points, bullet point analyze, bullet point compare means, bullet point paired samples t-test, and this one's really pretty easy. This is a lot more easier than the independent t-test, I think. Click over the first thing you want to compare. So in this case, we're comparing first week versus midterm. So everybody in our sample reported how much they slept during the first week of the semester, and everybody in our sample reported how much they slept during the midterm week before break. So we click over the first variable, first week of the semester, and we click over the midterm week. And that's all we do. And we press OK, and then there we go. We have the output. So very simple. So just put those in bullet points, and you'll be good to go. And then let's go ahead and look at the rest of the lab. So this number 2 should be the same answers you gave in the independent t-test lab, so lab number 3. So with the t-test, unfortunately, they give us a two-tailed significance. We don't have an option of one-tailed. And so when you have a two-tailed significance and you have a prediction, so let's just say that you made a prediction of which time people slept more, whether it was the first week of the semester versus midterm, which one was higher in terms of sleep. If you made a prediction about that, then you divide that two-tailed significance level by 2 to get a one-tailed significance level. And if that one-tailed significance level is less than 0.05 and your means are in the right direction, so your means can't flip, they can't be in the wrong direction. It has to be in the direction of what you said. It has to be consistent with your prediction of which week had higher amounts of sleep. So if you got the direction right and the one-tailed is less than 0.05, then there is an effect there. There is a difference between those weeks. So we have to divide it because two-tail slices up our thing, and one-tail we want to have, it gets a higher significance level because all of it is in just one end. So our rejection area, if you remember our second exam, the rejection area gets put into one end and it gets pushed in towards the middle. So the significance level gets higher in a one-tailed versus two-tailed. Okay, so we have two t-tests basically we're doing, and being asked to rate a results sentence, including effect size, I'm sorry, not including effect size, but including confidence interval. So the first one is first week versus midterm. So this is the file that you got for that on Canvas, and I'm going to highlight it. So if I can figure out how to pin this, then I should do so. It's actually already a photo, so anyway, it's already a photo. What I'm doing, I actually have to be able to write on it. So I can write on it. And I'll get the smallest area so I can expand it. You can see better. Here's our data. And so it's similar to the independent t-test output. So here we're comparing not two groups, but 2 different times for the same people in terms of sleep. We're comparing spring break versus the week after. Oh, this one. I think I clicked the wrong one. Sorry about that. There's one here. Oh, that's weird. It's about that. There we go. That's correct. Not sure what happened there. So first week versus midterm. That's the first one we were asked to look at. And that's part 1. the outs, and let me do the same thing for this one. And I'll expand it so it's easier to see. Okay, here we go. So we're not comparing two groups in this case. We're comparing 2 times for the same people. First week versus midterm week in terms of sleep. We see the means here. And just looking at the means, it looks like people got more sleep during the first week of the semester versus the midterm right here. And then we have the standard deviation. So, I mean, it looks like there's something going on, but we don't know unless we look at the t-test. So this is the t-test information right here. And so all we need to look at is 2 things. Here's our t information. So we have our t, we have our degrees of freedom, and we have our significance. So right away, what stands out to me is this sig. We can divide it, but you know, it's 0.1% chance of a type 1 error, and we can live with anything below 5. So this is less than, the sig is less than 0.05. So therefore, we reject, run out of space. So reject the HO. That sig is less than 0.05. We reject the HO, which means there's a difference. There's an effect here. And so we can write our first sentence. So people slept more during the first week of the semester, parentheses, mean, standard deviation, into parentheses, then during the midterm week, parentheses, mean, standard deviation, end of parentheses, comma. So we're looking at sleep. People slept more during the first week versus midterm week of the semester. And we report the means. First week is 7.20. Mean standard deviation 1.71. That's in parentheses. Midterm week in parentheses 5.95 for the mean, 1.48 for the standard deviation. So again, we're comparing people on sleep. First week was greater than midterm week. So now we put a comma. Now we report our inferential statistics. So we're doing a t, parentheses, 39 degrees of freedom, end of parentheses, equals equals 3.36, comma, p is less than 0.05. So just a very simple sentence, just like what we've been writing in the homework and on the exam so far. The only final thing we need to do is the confidence interval. The 95 CI was 0.50, rounding up, in brackets, 0.50, comma, 2.00, end of brackets, period. So we rejected the HO, so it makes sense that we don't cross the 0 in the confidence interval. So this is pretty straightforward, and just like what we've been doing on the homework and the exams, just make sure you're getting the data from the output, and it's pretty straightforward. So let's do this one. If you got the first one, you're confident, you don't need to listen to the second part. The second part I will go over right now. And let's fit so I can write on this and highlight things. And I will make it a little bit not big. Okay, so again, we're not comparing groups, we're comparing people at 2 times during the semester in terms of sleep. We're comparing them spring break, in this case, versus the week after spring break. So here's our means. So it looks like they sleep more during spring break versus after spring break, but they're a little bit close. We're not quite sure if they're going to be significantly different. And then we have the standard deviation right here. So we have our mean, we have our standard deviation. And so we have to also look at the t-test because we know the direction is spring break greater than the week after spring break, but we still don't know if it's significant. So we have to look down here at our t stuff. First thing I look at is this sig. Remember, we're supposed to divide it by 2, but even if we don't, it's still significant. But if we divide it by 2, we have a 0.6% chance of a type 1 error, and we can live with anything below a 5% chance. So we're doing really well. So this number down here in the sig is less than 0.05. When we have that sig less than 0.05, then we reject the HO. We reject the HO. So when we reject the HO, we're saying there's some difference here. There's a difference between these two means. Now we're ready to write our first sentence. So the basic structure, maybe I should just start with the basic structure before getting into the descriptives. So the basic structure is we're comparing people on sleep. So sleep was greater. Well, what mean was higher? This means higher. That's a 7, by the way. Oh, sorry about that. I was going to erase. Get out, ruler. I don't want you there. I'm going to erase that so we can see the 7. Oop. I can always rewrite. Okay. So we're comparing people on sleep, and this mean is higher than this mean. So people slept more during spring break versus the week after spring break. That's the basic structure. But we just throw in parentheses the mean and standard deviation for the 2 times that we measured people sleeping. So people slept more during spring break, parentheses, mean equals 7.93, comma, standard deviation equals 1.31, versus the week after break, mean equals, in parentheses, mean equals 7.13, comma, standard deviation equals 1.34. End of parentheses, comma, so we've given the descriptives and we told people which thing is greater than the other. Then we give the t stuff. T, parentheses, 39, that's the degrees of freedom. End of parentheses equals 2.65, comma, p is less than 0.05. That's our first sentence. Our second sentence is really easy. Our second sentence is the 95, whoops, no, I did that. The 95 CI was brackets 0.19, comma, 1.41, end of brackets, period. So again, we rejected the HO, so there's no surprise here that our CI does not cross 0. So 0 is not a likely possibility in terms of the difference between these two conditions. So there is some difference. 0 is not a possible thing where they're equal from a 95% perspective, and so we reject the HO. So that's it for lab number 4, and hopefully this was helpful, and I think it was a bit shorter than lab 3, a bit more straightforward.